Hi gang, this is to give you a little help with the second part of the week 2 written assignment. Let me go a little bit bigger here. And for this you're going to need a calculator, probably a TI-84 like this. A TI-83 also works. But if you don't have this yet, I suggest that you stop the video and go get hold of one of these. Maybe rent one at the Math Resource Center for 20 bucks for the term. As you'll see in this activity, a lot of the stuff we do with calculators is so specific that it's really a pain in the neck not to have one of these machines, okay? And I think you'll see as we proceed here why I emphasize that so much. I'm using my friend's travel picture here to cover up part of the page. So you've got Graphing Calculator Basics open here, and this is just kind of practicing with the calculator and finding out some of the functions and some of the pitfalls. Even this first item is a classic place where calculator answers tend to come out wrong, and that's because the calculator doesn't know what form the fraction is in. When you have a fraction like this with other operations above and below the fraction bar, there's always an assumption of parentheses in here. But unless you put them in when you're entering this in the calculator, you're not going to get the correct answer. So to make sure you get the correct answer here, use the parentheses key, do the operation, parentheses key. You can use division for the fraction bar, and then insert these parentheses. It's probably most accurate if you do a problem like this in one shot rather than breaking it down and copying down partial answers. Especially for greatest accuracy, if you want to round to the nearest hundredth or round to the nearest thousandth, you don't want to do intermediate rounding. So I suggest doing it all in one shot, but make sure you insert those parentheses. And there's a hint about that here as well. Let's see, down here, a couple of related issues when you're using the square root key that you can find on the calculator. It's a second function, so you hit the blue second key and then the key that's got the square root right above it. If you enter 7 minus pi, and you can locate a pi key rather than entering an approximation on your calculator, you'll want to make sure all of that is in the root. You know, you probably close the parentheses before you hit enter. Over here, you've got the square root key, and you want to close parentheses and then subtract pi to get a different answer there. Grouping is a big part of this. And then let's go down to, believe it or not, when we do this in class, this item here is usually the first one that's the big stumper. And what I get from people is, hey, where is the cube root key? How do I take the third root of 7 on my calculator? Actually, there is a cube root key that you can find if you go to the math menu. There's a button that says math, and then I think it might be under a sub menu. You'll find a third root key and also an nth root key where you can specify the root. But this shortcut is often very helpful, remembering from Math 95 or some other previous algebra class that the cube root of 7 is the same as 7 raised to the 1/3 power. So I would actually just on the face of my calculator use 7 and the exponent key, 7 raised to, I think the exponent key on here looks like a little caret. It's right here. There it is, little caret key that says raised to, and then put this in parentheses 1 divided by 3, and you'll get rounded to the nearest 100th. 1.91 is the cube root of 7. Further along, they ask, how would you solve this equation? And I hope this feels like a review of Math 95 where you did a lot of quadratic equations, lots of stuff with x squareds in it. So here's a quadratic equation standard form. I think from intermediate algebra you would say easiest way to solve this would be to factor. But if you work on this a little bit, you'll find this this trinomial is prime. You can't factor it. So you've got to go to plan B, which would either be solving by completing the square, or most fast and efficient, the quadratic formula. I think you'll encounter a quadratic formula review elsewhere in the videos or animations. You'll use this quite a bit in the course. So remember that the quadratic formula looks like, if you put it in this form, ax squared plus bx plus c equals 0. The solutions are opposite of b plus or minus the square root of b squared minus 4a times c divided by 2a, the quadratic formula. But this one is often a bugaboo for people to get on the calculator. So if I'm entering this on my calculator, here I'm just turning this on, and I'm saying the calculator won't know again about the parentheses around the top of the fraction, around everything on top. So I'm going to do open parentheses, -2, and by the way, the negative sign is different from the subtraction key, right? Here's a negative sign, and the subtraction key is over here someplace. So I want to use the negative key, -2, and then subtract second square root of, it gives me an open parentheses, 2, and I can use the x squared key, or I can use the exponent key, the caret, and a 2 to square that, and subtract 4 times, I'll put this in parentheses, I wouldn't necessarily have to, parentheses -5, close parentheses. And then I need to close the parentheses on the root, on the square root, and then I need to close the parentheses again. Let's see. Let me make this a little bit easier to see. So this is just the numerator of that guy. Opposite of 2, subtract square root of 2 squared minus 4 times radical 5, or -5. But look at all the parentheses, because I have to have all the grouping symbols paired. Now for the rest of the fraction, I'm going to do divided by, and underneath I just have a 2 and hit enter, and I'm coming up with that when I hit enter, -3.449489743. By entering this all in the calculator in one shot and hit entering one time, I've got this accurate to all those decimal places. And typically in my math lab, if you're doing an approximate solution, they'll tell you how far to round. I went ahead and rounded to the nearest hundredth here, so -3.45. And of course, the way the quadratic formula works, there are two solutions, -2 plus or minus. So this is just one of the approximate solutions to that equation. And then in number 6 it says, well, if you were asked to report exact solutions, which my math lab does a lot, you would not want to round, you would not want to evaluate the root, you would want to just simplify the square root. So let's see, if I simplify the radicand, the stuff inside the square root, I get -2 plus or minus radical 24 over 2. A common error in simplifying the quadratic formula is to cancel these 2's. I actually can't cancel these guys because I can only cancel a factor top and bottom, and so I need to have something that's a factor, meaning a multiplier for the entire top of the fraction. The short way to remember this is don't do any canceling until after you've simplified the radical as far as you can. So I want to look at that square root of 24 and recognize that there's a perfect square of 4 that could be factored out of it. So make that radical 4 times radical 6, and then simplify the radical 4. So this is -2 plus or minus 2 times radical 6. You encountered the need to simplify radicals in some of the distance formula homework, I believe, as well. Once I have that radical simplified, then I can look for a factor that's common to all 3 of these locations. In effect, this is a shortcut. I could factor a 2 out of the numerator, making it 2 times the quantity, -1 plus or minus radical 6, and then I could just cancel a factor of 2 above and below. And I get down to this expression for a simplified version of exact solutions to that quadratic equation. One of these, if you crunch this out, the one with the minus sign should give you negative 3.45 approximately, and the other one would give you a positive solution. Okay, now we're actually continuing with the same quadratic equation here, but writing it in the form of an equation. Instead of 0 equals y equals x squared plus 2x minus 5. And the question is, what type of curve is this? And you should remember that y equals ax squared plus bx plus c, a quadratic or second degree trinomial, will always give you a parabola. And then down here I've graphed that parabola, and here's something that may be new to some of you on the calculator. I'm actually pressing the this button here, the y equals key. When I click that, I get to this screen where I can enter that equation. I've actually got two equations in there. And then I'm going to hit graph. I just have the one equation turned on. And I have this graphed on a standard viewing window, negative 10 to 10 in both the x and y axis. And notice how this is shown in when you draw the picture here. How simple this is. These are important, the negative 10 and the 10, the negative 10 and the 10, because that shows you what window you've got in your calculator. It shows you, what is this viewing window that I'm looking at? And if you have that accurately reported, then you can just show a quick sketch of where the axes and the graph are, and you've got, the reader can tell basically what you're looking at here. A couple of other keys here that will be useful to you. This window key next to the y equals key actually shows you the window, shows you the minimum and maximum numbers for the x and y axis and the scale where you want the hash marks. So of course you can enter this manually if you want to change the window or change the scaling on the graph. And then there's a zoom key next to that, which is a shortcut way of setting various windows. When you hit zoom and the sixth option, which is zoom standard, that always returns you to this standard viewing window that goes from negative 10 to 10 on both axes. Okay. So then it says find approximate solutions by using the calculator. Well, we found an approximate solution up here by crunching out the numbers, but we want to look at a method for doing this on the calculator as well. And I see that I'm running out of time here, so I'm going to do a part 2 video where we look at the second calc menu up here and see how to find these approximate zeros, these approximate roots to an equation using the calculator shortcut. Okay, I'll see you in part 2.